Warm greetings from Dr. T. Pandichelvi, working as a Associate Professor, belongs to EC Department at Kamaraj College of Engineering and Technology. Now, I am going to present about my topic as transistor configuration and its application and working principle. The subject is called as electronic devices. The topic is from electronic devices, transistor configuration. Introduction about transistor configuration. First we can go for further configuration. We can see about the main introduction about transistor. Transistor is a semiconductor device. It can be from to build up the p-n junction transistor or diode. From p-n junction diode we can add one n type of material or we can add one p type of material. It will convert the semiconductor device. It is called as transistor. Transistor is classified into two types. First one is unipolar transistor and then bipolar transistor. In our configuration, transistor is bipolar junction transistor. Like this is a p-n diode. We can add one type of n material, means here we can consider the three materials. So, the first, this part is called as junction 1 and then this one is called as junction 2. In transistor we have three terminals. The terminals are emitter, base and collector. The emitter will be here and then this is base and then this is collector. Here the emitter, first we can see about what is mean by emitter. Emitter is emitting the majority carriers and then collector. Collector is collecting the majority carrier from the emitter value and then base. Base is a path between to transfer the electronics from emitter to collector. And then in p-n junction diode has a two different types of bias, that is called as forward bias and then reverse bias. Also in transistor configuration we have two different type of characteristics, that is called as input characteristics and then output characteristics. Transistor mainly classified into two types. First one is PNP transistor and then NPN transistor. We can add p-n junction diode. To add n means this is called as n type transistor and then in p-n junction diode we can add one p type of material, means this is called as PNP transistor. So, this is the logical representation and terminal representation of transistor. So, here this is the logical representation of PNP transistor and then this is the logical representation of NPN transistor. This is E material, it is called as emitter, base, collector. The current will be flow from outside, means that is called as emitter. The current will be flow inside to the terminal, means that is called as PNP transistor. The operation will be same only, but the arrow mark is different. And then this is the transistor current formation, how it can be flow from current here to there. Here you can see this is the emitter and then this is the collector and then this is the base. IC is represented as the collector current and then IB base current and the I is the emitter current. This diagram refers the two different type of p-n junction connecting together is called as transistor. Then we can go for transistor biasing and then operations of PNP or NPN transistor. Here I can consider one NPN transistor. So, the emitter will be connected to the negative terminal of the power supply, and then the collector will be connected to the positive terminal of the power supply. It's a forward bias condition. Here I can consider forward bias and then a reverse bias. So, again I can take N, P, N transistor. So, this is emitter. It can be considered the negative terminal of the power supply, and then the base will connected here. Then this is reverse bias. So, reverse bias collector is connected to the positive terminal of the power supply, the negative it can be connected to the base terminal. So, this is called as a reverse bias, and then this is called as forward bias. This emitter terminal connected to the power supply, the polarity is called as negative, and then the collector terminal is connected to the power supply in positive terminal is called as reverse bias. The current flows in NPN transistor means the I will be goes to like this, and then collector current is like this. Then we can go for PNP transistor. The operations of PNP transistor. So, this is base and then emitter, then collector. The positive terminal is, and then the collector terminal is connected in reverse bias condition. The PNP transistor, this side is forward bias and then this side is reverse bias. Also it is called as, it is input characteristics and then output characteristics. This is connected in positive, then negative and then positive. So, this is the operations of PNP transistors. Then we can go for our types of configuration. In general, the transistor configuration is classified into 3 types. First one is common base configuration, then second one is common collector configuration, and then third one is common emitter configuration. First we can go for the common base configuration. What is mean by common base configuration? The base will be directly connected to the ground, and then input ports depends upon the emitter and then base voltage, then output characteristics is depends upon the collector and then emitter voltage. And then common emitter is, emitter will be connected to the ground, the emitter and then base current is a input characteristics. In output characteristics, collector and then emitter voltages depends upon the output characteristics. Then common collector another name is called as common emitter follower. Here the collector will be directly connected to the ground, then collector and then base is depends upon the input characteristics, and then collector and then emitter voltages depends upon the output characteristics. So, this diagram shows the PNP and then NPN transistor is connected in voltage terminals. So, this part is input characteristics and then this is output characteristics. It is also called as forward bias and then reverse bias. The current will be flow on like this. Here we can consider the emitter current is equal to IB plus IC, because IB is a base current and then IC is a collector current. IE is equal to IB plus IC. The emitter will be emitting the electrons and then the base will be path of to transfer the electrons from emitter to then collector, and then IC is the collector current. If you can consider the IB mostly will be 0, that is called as no loss, means IB is approximately 0 means IE is equal to IC. So, this is the basic fundamentals about emitter current is equal to collector current for base configuration. Then this is the logic diagram circuit for common base, common emitter configuration. First we can go for common base configuration. Common base is nothing but the base will be connected to the ground, and then the input part, it can be depends upon the emitter and then base. Then output part, the common base, it is depends upon the collector and then base. Okay. Then here the important points about common base configuration is all current direction will refer to conventional flow, and the arrows in an electronic symbols have a direction defined by the convention. Note that the applied biasing voltage sources are such as to establish current in the direction indicates for each branch. Now I can complete my lecture series 1. Thank you for watching. Thank you.